Hello everyone, this is Mr. Underkoffler. Today we're going to be looking at part 3 of the guided notes on simplifying algebraic expressions using like terms. And part 3 is going to take us to the third page where we have the word problems and some geometry problems as well. All right, I'll do number 15 with you. Go ahead and follow along. It says the cost of a grill after 6% sales tax, which is the sales tax in Pennsylvania, can be represented by the expression G plus 0.06 times G. Simplify the expression. Well, this really isn't that big of a deal. Pencil's in your hand. G is the same as 1 times G. And then when you have 1G plus 0.06G, you can go ahead and add the 1 to the 0.06, which is 1.06, and then keep the G. Not really that big of a deal. Oh, by the way, if this 1.06 looks familiar to you, it's because on the percent unit, I taught you that 6% sales tax increases the price from the 100% of itself that it used to be, and 100% plus 6% would give you 106% of the original price, which is 1.06 times whatever that price was. In this case, we called it G. So that's how this ties in to what I taught you back in the percent unit. Now that I did number 15 with you, let's have you try number 16 on your own. So hit pause now, do 16, and then hit play when you're ready to see how you did. All right, did you already do number 16? If not, hit pause, because here I go. Same thing as you saw in the last one. C is the same as 1 times C. Add that, you're going to get 1.75 C. All right, problem number 17. I will do this one with you. Follow along. It says Jill bought 4 earrings that each cost $R, a purse that cost $50, and a pair of shoes, and I should have put that cost or put the word for, $80. Write a simplified algebraic expressions. I don't think so. Get rid of that S. Scribble that out. This should be the singular form. Write a simplified algebraic expression that represents the total cost. Ladies and gentlemen, underline this. Total cost of the items that Jill bought. Okay, why did I have you underline this? Because when you find totals in real life, you add the costs together. Unless you are buying multiple quantities of something at the same price. Well, we are buying 4 earrings that each cost $R. Now, I know that sounds weird. In real life, maybe they would each cost, I don't know, maybe $15 or something like that. If you bought 4 earrings that each cost $15, how would you get the money that you're going to spend? Well, you would take 4 times 15. Well, then that's what we're going to do here. We're going to take 4 times the cost of R dollars each. So 4 times R. No need for a times dot. Just call it 4R. Now, to get the total cost, you're going to have to add by the cost of the purse, which is $50, and add by the cost of the pair of shoes, which was $80. Who are the like terms? Well, it's the 2 constants, the 2 numbers that have no variables at all. Add them together. 50 plus 80 gives you 130, and there you go. That is the simplified algebraic expression that represents the total cost of all the items that Jill bought. Now that we did number 17 together, let's have you try number 18 on your own. Hit pause, do 18, and then hit play when you're ready to see how you did. All right, I'm assuming you already did number 18. 6 pens that each cost P dollars. 6 times P. A notebook for $1.25. Gonna add by that because we're finding the total of all these items. And then here's the part that's a little bit more interesting. It didn't say 12 and then give you the price of what the pens are. Well, it kind of did. 12 more pens. We already bought pens. Each at the same cost that he originally found. What was that same cost that he originally found for the pens? Oh, it was the cost of P dollars each. So, just like you did 6 times P, it's 12 times P, because it's 12 for each at the same cost that he originally found. That was the cost of P dollars. So yes, that was a little trickier than number 17, but hopefully you figured it out. And now we're going to use the commutative property to add the 6P and the 12P, giving us 18p plus $1.25. Do not add those together. We will never, ever, ever add unlike terms together. That's as far as you can go. All right, problem number 19. There's a word here that's worth underlining or highlighting on your page because this is a word that you need to be familiar with, and I know you've had it in previous years of math. The word perimeter. What does that mean? If you're about to tell me length times width or base times height, no. Length times width or base times height would be area. Perimeter is taking the lengths of all the sides and adding them together. So you're going to take this length and add it to this length and add it to the final length. And that's exactly what we're going to do. We're going to take 15K, go ahead and write this down, plus 20K plus 9, plus 3K minus 4. Now, before I use the commutative property and switch things around, commutative property does not work with the subtraction, so make that adding the opposite. And now let's put all these K's together, and I'm going to not only switch the order, I'm then going to group them together. That's the associative property. And then group the 9 and the negative 4 together because they're two constants, two numbers with no variables at all, which are like terms with each other. Okay, 15K and 20K makes 35K, plus 38K makes a grand total of 78K. 9 and negative 4, no calculator needed for that. Positive and negative, subtract in your head, you will get 5. Do not make this 78K. We will never, ever, ever add unlike terms together. 5 does not have a K, therefore it's not like terms with 73K. Okay, problem number 20 has a part A and it has a part B, and it's talking about perimeter. And then part B is kind of interesting. It finally then tells you the values of the variables, but don't do that first. Do part A first. So hit pause, do part A, then do part B, and then hit play when you're ready to see how you did. All right, did you already do part A? Hopefully you separated this as two different separate pieces of work. Got triangle 1's perimeter, triangle 2's perimeter. For triangle 1, you're just going to add all three of these side measurements together. I don't care what order you have them in. What I do care is that you make subtraction out in the opposite before you switch the order, putting all the x's together, putting the negative 1 and the positive 1 together, the two constants. 3x, 2x, and 3x is going to make 8x. Negative 1 and 1 is going to make 0. And normally you would stop there because you would say they're not like terms. But it's 0. Anything plus 0 is just that thing. That's actually a property called the additive identity property. Anything plus 0 is itself. So 8x plus 0 is actually just 8x. Yes, this is the only time you don't have to worry about like terms, is when you're adding by 0. All right, what about triangle 2? You're going to take its three sides, add it together. You're going to make subtraction become adding the opposite. Then you will group the x's together. And I apologize, but there's one more thing I should have done here. Negative x, make it negative 1x. So that way you can eventually add it to the other coefficients of 2 and 4. Now, we got three constants. The 1, the 11, the negative 4. Three of them. 2x, negative 1x, and 4x is going to give you 5x. 1 and 11 is 12. Take away 4 is 8. That cannot simplify. Do not make that 13x. The 8 does not have x. Not like terms. Part B. Which triangle has a greater perimeter if x equals 4? And will this still be true if x equals 3? Well, there's only one way we're going to find out. We're going to justify our answer by showing our work. So, left-hand side is where I'm going to take the perimeters that I already had from above. Remember these guys? 8x and 5x plus 8. And I'm going to replace the x with the 4. Now, that doesn't make this 84. This is 8 times 4. That's what 8x means. 8 times x. 8 times 4, boom, 32. Now, 5x is now 5 times 4. 5 times 4 is 20. Make sure you do order of operations. Multiply before you add. 20 plus 8 is 28. Well, you can see the 8x perimeter was bigger than the other one, so triangle 1 right now has the bigger perimeter. But will that stay true if x equals 3? Only one way to find out. Instead of 8x, it's now 8 times 3. Instead of 5x plus 8, it's 5 times 3, and then plus 8. 8 times 3 is 24. 5 times 3 is 15. 15 plus 8, barely under 24. So in both cases, triangle 1 had the greater perimeter for both when x equals 4 and when x equals 3. It barely made it for when x was equal to 3, but it still was. So there you go. That is the answer to the question. All right, that concludes the guided notes, all 3 pages of the guided notes called Simplifying Algebraic Expressions Using Like Terms. Thank you for watching. We'll see you next time.